everybody!
Hey, we're live, everybody. Welcome, welcome. Hello, hello. Be sure to join the Discord if you're not already. Get announcements every time I go live and be a part of the streams as I'm about to join. Hello, everybody. We're live.
Hello.
We're here. Welcome. We're doing it. C++-ness.
Local said it was gonna be right back, by the way.
Awesome. Local will be here soon. We're just gonna get right into it, I think. So
Sure.
we're working on the intercept library. Here, I'm gonna do this. We're working on the intercept library. Let me open chat. There we go. And we're just gonna get right into some stuff. Okay, so I'm pretty sure that we just have to get started here and convert a bunch of types.
You were sharing your screen, just saying.
Oh, in the Discord. I forgot I gotta do that.
Otherwise, we're like 30 seconds apart or something, probably.
Let me figure this out. There's too many buttons. Okay.
So Sema, it would seem. Oh no, that is not Sema. I saw convert and immediately went Sema. That's why.
Yeah, this is IRGen. So this is basically converting an intercept type into an IR type. So basically, we just have to handle all these cases, right?
Yeah, it's a rather boring thing.
Okay, I figured that's a good place to get started. Where are all the cases defined? Where are all the intercept types? In AST.HH?
All of that is in the AST, yes.
Okay, so
the way it's organized is most of the enums are at the top, and then like the type class is the root. Well, I'm saying the type class is, but Sema node is the actual root of everything. But that's just so I have a common place where I can put all of the type checking stuff that marks if a node is type checked or not. You can see it's I think directly above that. is the
I see.
semanode class that just has the state of semantic analysis and a few functions to check that, because and also it makes sure that once a node is marked as error that you can't then change that anymore, stuff like that. So that's the only reason why there's a common base class for type and expert. But yeah, these are all the types, and since it's an enum struct, you'll have to do I think type. I forgot whatever it's called, like type : whatever the thing is called.
Yeah. So this is, yeah. We're in the intercept namespace, so this should be fine.
Yeah, probably.
Do I have to do type kind?
I forgot what it's called. It's probably type. It's just kind. Yeah, it's just kind. Mm.
How many are there? Like that?
That should do it. Yes.
Ugh. Okay.
LSP is not having it. There we go.
Not so red says hello. Hello, not so red. How's it going? Good to see you again.
White space that sticks out like a sore thumb, or like, yeah.
Yeah. Okay. So for a built-in type, what built-in types do we have?
Okay, so built-in types are basically anything that is not a like CFFI type and that doesn't really fit with that. Those are intrinsics, and that doesn't really fit with anything else. And all of these kinds are separate structs that inherit from type eventually. So there's a built-in type, and currently that's just bool byte int unknown. Unknown is just used in like in the parser if you have type inference, for instance. And overload set is only used for overload resolution, so neither unknown nor overload set should exist anymore at this point. If they do, then that's basically an error, and you can just return whatever.
Did I do that wrong?
No, that is fine. You will probably have to.
Where do I put the
No,
star?
you're not in the intercept namespace, so that should work.
This might just be my, yeah.
It might be too few template. Yeah, that's definitely.
Yeah, that's that's nothing we need to worry about.
Probably your version of ClangD is too old to.
Oh yeah, the one that came out 3 months ago.
Do you have that? Is that the ClangD version you're using though?
I'm using ClangD 1503.
Okay, that's a bit older than 3 months, but okay.
Is it?
But ClangD, yes, the latest LVM release is 16.06. But yeah, I don't know what it's complaining about here. Maybe I'm just being stupid and missing something, but this should work.
It's
because the syntax for as is you pass in the class name as a template parameter without point or anything, and if that's for the template parameter, and for the actual parameter you pass in a pointer to an object that's part of the hierarchy. If that pointer is const, it also preserves const, and you don't have to write const class name or anything.
That makes sense. We're gonna build this thing, I guess. You can see I just get pulled.
The reason why, so the way built-in types work in the intercept AST is there can be more than one instance of a built-in type. So for instance, you could have 10 instances of bool, and the reason why that's the case is because of location information. So that every occurrence of bool should have the location of where it actually occurred in the source, so we can issue error messages appropriately. That's why that's a thing in the AST, but that's also why that's not a thing in the IR. Like the IR types are supposed to be unique.
That would be an issue.
Well, yeah, if we're trying to.
Okay, I'm trying to make a reference from a pointer.
Oh yeah, you need to do reference that probably.
So, what?
Of type, yeah, that's in the whatever calls that, so apparently.
So I see, so it's probably here. This.
Yeah, you probably need to reference this, there we go.
Okay. That's one. Control reaches end.
Yeah, you're not returning anything in here. So I think what I would suggest is don't have a default case and at the end put LCC unreachable. And the reason why you don't want to have a default case, that's a macro. You can't know that it's LCC underscore unreachable. It's a macro.
Of course. Because this is C++, so we naturally use macros.
Macro. What was I saying? Also remove the default case, please. In general, prefer not to have a default case with these kinds of things if you're matching everything anyway, and just put something afterwards or something. And the reason for that is that the compiler will error if you add a new type kind. It will error here and tell you that, hey, you're missing one, because I've set up the warnings to do that.
Okay, so switching on the built-in type, we should probably do the same thing.
Yeah.
And this is going to be built-in type.
Yeah, these are a bit verbose. I think it's currently called built-in kind. So it's built-in type : built-in kind. We should really move that out of built-in type. I've done that for some other things, but not for that yet. So basically, bool is, I think, in the II, it's just called I1 because that's how we represent it there.
What have I done?
Int.
That's an interesting one.
Yeah, you only need void. Like unknown and overload set, those should no longer exist really, because that's an ill-formed that's just temporary. So for that you can just issue an ICE or something.
Leave this.
We don't have well, in C++ you can write left, like within 2 square brackets fall through. But for adjacent case labels you can just not write that typically. And in here just an ICE or something. Sure, that also works.
How do we ICE?
So an ICE is a type of diagnostic now, so you'd have to write diag : ICE. You don't need the LCC : because you're in the namespace anyway, but sure.
So we're gonna ICE, and then it's just the regular. Okay.
You can just you can give it a context and location, or you can just put in a message.
And I'm just gonna say overload set invalid built-in kind present during IO generation.
Yeah, something like that.
Should we have a way to specify this is from intercept?
I mean, it's gonna give a stack tray or a location anyway if it's an ICE. I mean, an ICE, I'm not sure if that gives I should probably change it so it does include a location because there's a way of doing that with default parameters.
Yeah.
It should also give you a stack trace though if you're on Linux. So
okay,
that's
then
not
we'll
gonna help you. But so you still need to add the Windows stack trace back in or something like that. But yeah.
This is an interesting one. What do we return for void?
So for void, so we need the IR has equivalents for that sort of for these.
So it has void tie? Is that what
it has. So for the IR, we don't have a built-in type class, which is because in the AST we need that because we're going to have multiple instances. In the IR, we only have one instance of void, so we can just compare against that specific instance, and we don't have to have a separate built-in type class in the IR. So for this, you can just return LCC : type : void.
And even though we're in the LCC namespace, we need to specify LCC because there's an intercept type, and we're also in that.
And I think in the IR, it's currently called like void TY or something. Yeah. Yeah, that should work.
We need an egglet. Fuck you. Okay, this is one of my favorite types of questions. With what finger do you press M, and what key is your M?
Are you going to pull up your keyboard layout? Or?
You know it. it's a QWERTY keyboard, so M's in the regular spot. It's orthographic, so it's a little different, but ortholinear. I always get that wrong. So yeah, it's right here. I press it. Let me think about this. I press it with my index, or my yeah.
Mm.
I press with my index.
Yeah,
As you can see,
M is in a totally normal position. It's right above square bracket and right two keys to the right of the two left parent, one right parent key.
yeah, naturally. I mean the
So yeah, just
Emacs
what you
M.
would expect.
Meta. He's talking about Alt. So that is this mod tab key I have here. So if I hold this, it's the modifier Alt, left Alt. But if I tap it, it's the minus key. But if I hold it, it's Alt.
That's interesting.
Yeah, I don't have a lot of keys, so minus
I
up
see.
here used to be backspace because I had a lot of bad habits. And then here I had to put 6 and here I had to put 5, but I've gotten rid of those now.
I see.
And then I for right alt and right control, they're up here on my thumb cluster. Hopefully that helps you, Mr. Mugume. Zirkos86 says, yo, what's up, Zirkos? Okay, void type, done. Int type.
Int is interesting because the size of int depends on the target. So we need to get the size.
Wait,
we need to create an integer type
is this
with the right size.
Isn't this? Oh, yeah, that's true. So we need to basically
get the size
switch
from the target. You don't have to do that. We can just get the size from the target. And the target is stored in the context. So
Okay, we have a whole target thing
yeah,
now.
this is basically a target has all of this, and as you can see, it has an intercept. It has size of int and a line of int in case you need that. And you can get the instance of the current target that's currently in use from the context that's stored in the context.
Okay. How? So target, I'm noticing, doesn't include like calling convention or elf or anything like that.
Well, x86-64 Linux is not going to be much else other than System 5. And it's probably just going to be an elf and nothing else. And the same thing goes for x86-64 Windows. It's more like a target triple approach here.
So this is a target triple approach. So
yes,
we're gonna want to end up with like the OS, the architecture, and then the calling convention or kind of category.
It's not really. The third is typically the vendor, not the calling convention, because the calling convention is not going to change irrespective of what kind of Linux you're on, what kind of x86-64 Linux you're on. So architecture and calling convention generally go hand in hand.
That's true. That's true. And a lot of modern target triples have the vendor completely left out, and it's just architecture and OS.
It depends. Like my default target triple is still. I can actually test that with Clang. I can get to do Clang
Dump machine.
target triple for me. It's x86-64 Red Hat Linux GNU. But the default I think is x86-64 unknown Linux is like if you don't know what it is.
And then the my example was because in Lenser OS, the tool chain is an x86-64 Lenser tool chain.
I see, yeah, makes sense.
Because the vendor was like PC, and the advice was to either use PC or just leave it out. And I was like, I'm just going to leave it out.
I see. Also, the way this works, if you scroll a bit down, you'll know there's this target struct whose only purpose is that thing is a friend of target, and it's the only thing that's supposed to create target. That's so people don't get the idea that they can suddenly create targets and it'll work. No, only the targets that are defined in here are guaranteed to work. So this is to make sure you don't suddenly create new instances, because probably some backend code is going to have to check if this is this target, do this, otherwise do that. And if it just supplies some random other target, then it's going to crash. So
that makes sense. Morshana says, hey all. Hey Morshana.
Yeah. And as you can see, it's context, so all of this is initialized at compile time. The way that you have to declare that is a bit horrible there, because there has to be an out-of-line declaration down here. This is a bit scuffed, but it works.
It's no different from what we'd have to do in C with some extern BS. It's a little funky why one of
Although
them is
just
in it.
doesn't highlight inline.
Yeah, it's the tree sitter is why. If I was
Mhm.
just using the regular
I see.
mode, it wouldn't.
I see. Okay. It's also in. I do wonder why did I make one of them const exp when the other one const init? That seems a bit weird. I'll have to
Okay, that's what
investigate.
I was wondering. Okay.
The difference is, by the way, in case you okay, that's an interesting one. The difference between const exp and const init is const exp guarantees that it's initialized at compile time, but it also makes it const. So const exp is like a constant. Const init just cares about the initialization part, but the resulting object isn't automatically const. So
So
you
we
can
don't need
declare an object
this.
as const init to ensure that it's initialized at compile time, but you can then mutate it later on. Don't do that. That's because the target is const. This is our const pointer, and because of how it's declared in the this is a member, so it's a bit scuffed. Normally, you'd be able to leave out the const after the pointer there, but because this is a member, things are a bit weird.
Is this meant to be in bits?
Yes, that's in bits.
Okay, I was like, I'm
It
kind
is
of
in bits. Yeah,
confused.
it
And
does
then it,
say that at the very top too. At the targets class, a target class at the very top of this file somewhere.
oh
All
yes.
types of elements are in bits because this is going to be painful otherwise. If we have like an I-17 and then we need to convert back and forth all the time.
So int, we're gonna have to reach into the context
Yeah.
through to the target.
Yeah. You need to pass in the context. The context has the target.
Reference.
You don't need to drop the C colon context. There's only one kind of context.
I guess.
Typically, I pass the context by pointer because it's stored as a pointer everywhere, but that doesn't really matter.
We'll go for that. And then what was this to? Convert. Do we call that ever? We do. We're going to call that with context. And we're going to call this with context.
So the way this works now is that a lot of things, for instance, to get the size of a type, you also need to pass in the context, because if it contains an int, it needs to get the size from the context and stuff like that.
So we now need to make an IR type.
Oh, actually, that's interesting. That's also another way of doing it. You need the context either way, but you can also just ask the type what its size is. So you can do in arrow size, and you will have to pass in the context to that because it will eventually have to grab into the target, but you don't have to do it yourself.
What's in the
Function.
target? Oh, it's a function.
Yeah, so you could do this, or the alternative is in arrow size and pass in the context. Either way works.
What is in arrow size? What do you?
Well, in right now is what you call the type.
Got you. So you're saying this thing has a size.
It has a
Isn't
size.
this in bytes?
It's in bits.
It's in bits. Everything's in bits now. Okay.
Yes, everything,
So,
unless it says byte size, it should be in bits.
okay, and in this case, we have an int. Oh, this is the wrong place. And in this case, we have an integer type. So we're going to have to call integer type, and we're going to have to call LCC integer type get.
I believe it is get, yes.
This thing.
Yeah, you also need to pass in the context to that. Everything needs the context. And in there, you apparently declared it with a reference, so I have to dereference it.
We're just gonna not do that as the solution. It's just is there a
Sure, yeah.
is the operator new? Did I do this wrong?
Context, please. Sorry, come again.
Did I do this operator new wrong?
Okay, there's two answers to that. This is an operator new that works, but it also misses the point because it's supposed to store the type because it's supposed to unique the type in the context of it. Actually, well, in this case,
We can't.
okay, it's funnily enough that yeah, it should store the type in the context, so it can then later be deleted when the context is deleted. But
I
other
see.
than that, it doesn't have to do anything. Yes, so
Okay.
it will allocate, but it will also leak currently. In size is a function. You need to call that, and you need to pass in the context to that, because it needs to grab target information from somewhere. So for this, you can just use I1 for this and type. Yeah,
There we go.
there we go.
Not too shabby.
That's done. Yeah, this is not really that complicated of a function. It's just annoying to write. Like this is, I have to write that every time I do stuff with LVM to convert something to an LVM type.
Is not implicitly convertible to int.
That is fascinating. I think it's having a stroke or
Ugh.
something.
I'll be right back.
Hmm.
Vocal's been gone a long time.
That's true.
Okay, what were we doing? What are we doing? We've done it.
I think we were converting types.
We're gonna have to write a function now, though. This one.
Oh yeah, you'll have to write that one.
It's also no longer a reference.
It is no longer a reference. Oh, a function type get is no longer a reference either, it would seem.
Where would that be?
Oh, that's just what is this somewhere? Ah, it's maybe in the IR where we.
It's
Yeah,
here.
there you go. That makes sense.
This is exactly where we need to be.
Hmm.
So now it fails during linking because we need to write integer type get.
Mm-hmm.
Just gonna steal that. And it'd probably be easier
Oh
to steal
god,
it from
unsend
here.
long.
Where are we? This thing, please.
Mm-hmm.
Okay.
Sure, you can also leave the trailing return type. It doesn't matter. Typically.
I have returning.
Hey.
Ooh.
It's local.
Mhm.
Hmm.
Almost choked on my water. Ah. Why'd you
I'll
have to talk
probably
while I
do
was
the
drinking?
type catch thing in one full swoop because
Nice.
yeah.
That would definitely help. Is that enough?
Probably. Let's see. Is
Private.
private within this? Wait, hold on. What? You forgot. I see. There we
And
go.
C++
I was
is
gonna say,
crazy.
static
I was
function
crazy
of a
once.
class is private within
Oh,
the
no.
same class. Well, it shouldn't care. So yeah,
It
it's
builds.
linked. It's not gonna do much, but it's building. So
It should probably print out.
it should probably just error somewhere because
Yeah,
it's
there we go.
unreachable. Yeah, there you go.
Iogen CC.
See, it does. Apparently, it does use.
It
Oh no, that's
does.
unreachable. Reachable, of course, gives you a location. Yeah. Also, you can see the. I'm not sure if you've looked at the AST printout yet, but you can see that implicit conversions are now in the AST properly.
Hey, what does that mean?
You can take a look at the printout that was just on screen. You'll see
This
some
thing.
L value to R value conversions. Yeah,
So we have a
basically
plus.
This is a binary expression that adds two things, and its operands need to be R values because in this case they're references and you need to load the value and then add those values instead of just adding pointers together. Right, you want to add what's stored in those references. So the only thing that L value to R value does is if it's a reference, it loads the value, otherwise it just passes it through. And in this case, we have two name ref expressions, which is what the parser generates in the semma, then resolves them to the variable declaration that they point to. And the name ref expression that points to a variable is always a reference. so it doesn't get loaded until it needs to be loaded, which is where the L-valley to R-valley conversion comes in. And the entire binary expression is also in a cast expression because that the return type, the byte is cast to int there, and that's then returned.
Fantastic. For
So there's a
FFI
lot more
type,
cast expressions now because of this.
how are we going to do FFI in the IR?
We don't. We just converted the underlying type. I believe Semma resolves FFI types to their underlying types somewhere. Does it? I forgot.
I don't know.
Well, is there anything using it? I think the signature of main uses it currently for parameters. So we don't do anything here. So what you're supposed to do instead, apparently, is to just okay. So what you can do instead is the
Use
way
the
FFI types work is that like built-in types, there are a predefined set of them. And for each of these, the target stores what the size is. So you just do the same thing that you did with int, but for all of these, basically. And the thing is, the IR doesn't care about signedness, right? So you should probably just be able to call integer type get and pass in the size, and you don't even have to do the switch, I think. Because I think size can handle FFI types, but you can check that in the implementation.
So are we assuming every FFI type is an integer?
Currently, every FFI type is an integer.
Okay.
And even
So
yeah, currently it is.
It's not in lie yet, but we're not doing that.
so it's literally the
check
same.
It should be that. You can check what size does, just to be sure. And if it doesn't do that, it should.
Where would
It should, but I'm pretty sure it does.
AST.cc.
Yeah. There you go. That's. And I like to put them on one line, otherwise it gets horribly verbose with way too many braces. But yes, you can see it does grab the size from
okay?
the target.
Fantastic. Named.
So yeah,
This is just
the way I would format this is I would not use the braces and just put it on the same line. Also, break and the after return is a bit cursed, but okay.
Yeah, break after
We'll fix
return
it
I
up.
don't do, but otherwise I love having braces around my cases.
Not if they're one line, otherwise sure. But if they're on one line, you
Mm.
because the main
If the
problem,
only word is break, then I do that.
the main reason why I don't like this formatting is again the thing that I don't like. I prefer fewer lines of code, and in this case,
Yeah,
you
but
end
so
up
well.
3 lines of code for every case instead of 1.
Yeah,
Which
but
is,
Lens is writing the code and you're not.
but I may have to look at it.
Okay, but Lens has to look at it too, and he's writing it.
So what is this? A name type? Well, that works differently now. A name type. Well, actually, no. Name types still work the same. They are just types are just replaced. Expressions stay where they are. Like a name ref expression is never removed. It just it points to the thing that it actually is.
yeah.
But I think name types are just replaced currently because we don't care as much about that currently.
So assuming we have a pointer 2.
Currently, only have one pointer type in the. So we currently in the. I'm trying to see if we can get away with just opaque pointers in the IR
We should be able to.
because
In the
there's not
AST?
much.
No,
The
the IR.
AST there is a pointer type, but for every pointer type and also for just reference type, you can just return the same opaque pointer type that the IR has.
So
It's just called PTR. Yeah, that thing.
yeah.
And the same thing for reference
Peter
because at this
Tyler.
point references are just pointers. If they manage to survive till here.
Shouldn't you add like a size to the pointer?
Nope.
Or something like that?
What for?
I mean, if you're not gonna store the type of the pointee, then
On load or
you
store,
need-
you specify the size of the thing you are loading or
oh, it's
storing.
on load.
You
Okay,
never
okay.
need the
Yeah.
size. The only things you need the size of the pointee. You need the pointee type at all for our loads and stores. So instead, the load and store just specifies what the type is, And
Oh,
and the
okay.
only other thing is if you're calling a function pointer, but then you'll also know what it is. That's like
Yeah.
the three cases I can think of the way you need the pointer, but otherwise you just don't.
Yeah.
So the
Anytime
way
you need
this
to
works,
do.
I need to explain how constant expressions work here.
Oh boy.
So in this case, the array size, you should just be able to call dimension on the array type, and it will grab that for you probably. So this should have a dimension member that gets it as an integer, if I recall correctly. Yes. If you call that before Semma, bad things will happen. But this is after, so it's fine.
So type with one element. I gotta go down the linked list now. You
Type
love them
with
now.
one element because we have pointers, arrays, and references, and maybe something else that has all of this, and I don't want to copy all of this into every single one of them. So I
In
factored
this
it out.
case, it's like 2 lines of code, so I'm with Lens on it. But if it were like a 5 fields or 6 fields, then then I'm on yours.
Well, it also depends on
Ooh, I get to ban somebody, everybody. Let's all
Oh,
celebrate. Do a
ooh.
little banhammer dance.
Hammer dance.
Okay.
Brilliant.
How do I do this? Oh, I don't even know how. Okay, there we go. I figured it out.
There we go. But yeah, if you're interested in figuring out how this dimension thing works currently, if we go back to the array type in the AST, we can check that real quick. Because you'll see that it stores an expression. So the size is an expression, obviously, because it could be 2 plus 17 or whatever, and that's also fine. And what Semma will do is everywhere where the size has to be known at compile time is it will evaluate that and it will insert a constant expression, which basically just has the value as well as the original expression, and that way you can access the value immediately
Nice.
on 1515 there.
Cool. So it just does a constant evaluation at compile time of the AST. Is this an AST evaluation?
Yeah. The actual evaluation is on line 1500. The evaluate function does that.
Yeah.
You can see what it does. It's pretty much what you'd expect. It's a very rudimentary constant expression evaluator.
We'll get into it at some point.
It may be in eval.cc. I forgot where I put it. I think it might be in a separate file.
It's here.
Yeah, there you go. That's all it is.
A bunch of stuff isn't const expert yet.
Yeah, currently at least.
Oh man, a lot is though. Cool.
Mm-hmm. All the simple
Functions.
stuff is.
Actually, hold on. There's something I didn't do.
Oh, there. You can see that there is a.
What have I
Oh,
done?
no.
There is a constant expression whose whatever it contains is currently not being printed. Apparently, that is interesting.
Byte.int.
Yeah, because if you try, for instance, to declare an array, and it should show you what's in, but maybe I forgot to add that because I'm not sure I've fully implemented the AST printing yet. Because for some expressions, it might not be printing the children just yet. But yeah,
That makes sense. That makes sense.
Never ignore your children.
No, and also.
if you
I have to call convert recursively.
Yep. That's how it goes.
What did I call the things? Okay, just context and in. This is in.
Yes.
Okay. Now it should complain when it links instead of when it builds. Have you implemented the tokenizer for all of this? I haven't, but it is implemented.
It is implemented.
It's probably here, I would presume.
The AST, it's in Alexa.
There's literally a Alexa file. That didn't exist
you go.
before. Here's the
It does now
tokenizer.
because that's a bit cleaner to look at. But yeah.
It's not too bad.
Keywords at the top, look ahead. The next token function handles most of the thing.
The worst is macros. That's the complexity of all this.
I haven't tested them yet, though. Just so you
Oh,
know.
no.
But they're technically implemented.
Yeah, fantastic, fantastic.
Well, that's kind of implemented technically.
I am trying to make my own tokenizer from scratch. Oh, you guys used Lex. What?
No.
We did not use any external software. We just wrote the Lexer.
It's just Alexa.
It's a class called Lexer. It's a
Mhm.
kid called Finger. I'm such an idiot. This one might get me. It's so stupid because it doesn't even make any sense. And no one's going to get it.
I didn't get it. I didn't even hear what you said.
I know. It is going to be
Neither
it's
do I.
a kid called Finger. And if you don't get it, you'll never get it. It's just so
Well.
stupid.
I'm in the dark.
Class called Lexer.
Hmm.
Okay. Yeah, this is the Lexer. We definitely implemented it ourselves.
I think most of local wrote most of it. I did the macro system and also like fixed a few things because it was just there were a few things from in the old implementation that weren't exactly handled too well, so
Yup.
they're handled better now.
I did the grunt work. He did the finish it up work. Same thing with the AST, basically. I did all the copy pasta that Eternal doesn't want to do. And he made it actually work.
Why are you mad?
I can respond to that one. Two Step is asking about the, I think it was, what was it? The Bloomberg or whatever talk by Chandler Caruth, I think it was, where he talks about how they're implementing the Carbon compiler currently with a data-oriented design approach to optimize compilation speed. It's definitely very interesting. We're definitely not planning on implementing that. We're sticking with a more traditional EST. In fact, the one that I wrote I basically came up with, not really came up with, but that I suggested we use and that we're using currently is most similar to Clang's AST, I suppose, at least in how it's accessed, definitely not in how it's stored. The way Clang allocates AST nodes is also very interesting. But yeah, what the Carbon thing is doing, at least in terms from a compiler design point of view, is definitely interesting. Is also what they mentioned is that they can also, because of course they're designing a new language, so they can also, if need be, change the language in such a way that it's easier to parse and store and compile and so on, which is not exactly something you can do with C++. And that's also part of why C++ compilers are complicated, because the language is. But yeah, it's definitely a very interesting subject.
Their performance
I just
targets
watched
is
that
also
talk
really
like the
interesting.
other day, so
See, the performance targets, they plan on like parsing 10 million lines of code in 1 second, sort of thing.
yeah, I think it's lexing 10 million lines and parsing 1 million lines or something like that. I forgot what it was.
No, I think it's parsing 10 million lines and semantic checking 1 million lines of code.
Could also be
And
that, yeah. I forgot what it was exactly.
in
That's my
much
goal too, honestly. Sema for 1 million lines should not take that long for Laia or honestly anything.
I
Yeah.
think it's actually really, really hard because if you do the math, like you only get 1 or 500 nanoseconds per line or something like this.
That's quite a bit.
You get
It depends on what you're doing. Like, if I was doing I wrote a Lexer in assembly a while back, and I think it was at like 2 gigabytes per second or something. Lexing.
Ooh,
So
okay.
Lexing is really not. It's the thing about Lexing is there's not much to optimize, and the things to optimize are fairly trivial. So that's also why I don't really focus on optimizing the Lexer or anything, and why I don't even try to do that most of the time, because it's just such a small part of compile time. It's not really worth that much.
I don't think we're going to hit 1 million lines per second anytime soon for a variety of reasons. One, we're nowhere near optimizing this compiler for any front end, let alone any of the middle end or back end components. Two, we don't have a million lines to compile, nor a
Yes.
substantial amount of lines across a substantial enough files to like guess. We don't have 100,000 lines in like 100 files or something, right?
Mhm.
We have like 5 lines in like 5 dozen files for intercept. So we can't even accurately measure that. We'll have to
Yeah.
get a substantial amount of code in any of the languages we want to optimize. So that's going to take time.
Mhm.
And yeah, then we got to do all the optimization work. It's going to be a while.
The most important thing is actually correctness. Once it's correct, then
Yeah.
Mhm.
Yeah, so we'll add that to the list of reasons it's going to take a while.
Yep.
There's many reasons we won't get there anytime soon.
Does this look correct, Saraid?
You're converting the return type in each of the parameter types. I think that's right, yeah.
Looks good to
Alrighty.
me too.
You should definitely be moving that vector instead of copying it. But yes. That's something you'll get used to if you program in C++ for a while.
I'll just
Eventually
wait
you
till
just-
you yell at me, yeah.
There you go. Pair programming at its finest. Do whatever you want until somebody tells you not to.
Mhm.
This is something that gets easier over time. You'll just get used to writing move every time you're dealing with a vector because you see for me it's like, I'm passing in a vector. Do I need it after this? No, so I should be moving it probably. Not probably, definitely in this case.
Manual borrow checking.
Ooh, for struct types, sure. Those did you just
Yeah?
sorry, something about this is not right. I don't think a struct type takes a single element type.
Yeah, that's true.
Yeah, I think that's array type, I'm pretty sure. Yeah. That's a bit too much copy pasta, I think, what happened there. Um,
Element.
and the struct type also doesn't need a length, probably.
True.
Mm-hmm.
So what do we have? Just member types? It's pretty much all a struct is.
Member types, probably, and
Which is what we have here and here.
yes.
I just didn't do that.
Yeah. And then struct layout needs to be calculated, but we can do that later. That's not that important. The AST also calculates that, but the R should also do that itself.
Okie
And it might make sense to just if we want to support align as and stuff like that, to just insert padding members in between, so we can deal with that a bit more easily. And I think member access is currently index based, so we can encode that in the IR that way, and that's a lot easier to optimize than like trying to decipher series of adds and or was it multiplies that, and also we can easily translate that to get element point in LLVM. So void value not ignored as it ought to be. That is a very interesting error.
It's twice.
What in the world is it on about? Interesting. What happened here? In here. You're jumping around a lot. Param types. Did you forget a semicolon? No, it's not that. Interesting. Probably on line 65, because something is not right there.
That's not where it was pointing, was it?
Not at all.
No. Which is, maybe it just errored somewhere later on because of that, or maybe there's some other typo in here, like the LSP is going a bit crazy, so it's hard to figure out what's an actual error and what's just it being weird.
It's not my
It's
fault.
probably
The
because you wrote-
language is so complex
it
that nobody can make
Yeah.
tooling for it. That works.
C++ is very hard to parse, to be fair, yes. The only way to parse it properly is with a compiler.
He moved.
There you go. Nice.
Let's go. I'm so proud of you, Linz.
I'm dying inside.
Don't worry, I'm aware.
Mr. Mugame is saying BNF or eBNF. I'm not sure what that's in reference to, but we're definitely using eBNF because BNF sucks. Like, the only things it has is just alternatives, basically, I think. So you have to do the nonsense with empty productions all the time, and it's just horrible to write a grammar like that. This is the
Ugh.
looks like the AST. That's
So
what
we don't
member
have member types.
We don't. You can add a member types with a. You can do some standard views thing to map that.
I'm gonna leave that for you or later.
I think you can just copy it from param types and replace like one thing, but sure.
Bum, 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 bum.
Auto pointer M as
Yes.
a member. It's not
Mhm.
necessarily this. It's now a member. What the hell is a member?
You should probably. Yeah, it's a member, so you should loop over that by reference probably. So auto ref.
Yeah. Const auto ref.
Otherwise,
and
you
we just need the
copy it
type.
every time.
And
Const auto ref, even better. There you go.
You can't hear it, but I'm clapping.
hey. And then this is convert.
Let's see if I can find the.
Could you link the videos? Okay.
Someone's is asking about. I'm gonna link the CPP Now talk about. Oh yeah, someone already linked it. There you go.
Hey.
Can you share that in the Discord? I don't have Twitch chat open.
I'm going to put that in the
References?
Oh, I figured out what the
sources.
BNF or eBNF thing is up to. So Gumaranda asked, question, how can I define my language?
Yep, I'll do it.
Your error message is still here.
So, oh, okay. Yeah, so it's a cast problem. It doesn't like one of your types. And this was in the return type and the.
Is it
I
not
put
called,
that talk in resources if anyone's interested.
it's not called function type. Fantastic.
Is it func type then?
Well, it's probably called func type.
Of course it is.
You can blame local for that. I didn't call it func type. I'm pretty sure.
I don't remember if or what you forgot to type on one of them.
Type.
Type. Mm-hmm.
I don't remember why I picked func over function because
That's-
I'm pretty sure Lia's AST uses function.
Probably
Well, I
because of
don't know.
expert. Because I abbreviated expression as expert.
Probably because you
see,
keep
what is it
talking
on
about
the-
typing less code, so I made your code shorter than my code. Yeah.
It's probably members. Oh wait, func type has no member param types.
Does it have
What are you?
parameter?
It does have param types.
That's the function
so-
declaration, not the function type itself.
Yeah. Well, okay. The reason for that is that the function declaration stores parameters, not types, but the function type just stores the types. So you should just be able to call params on that.
It all makes so much sense, right?
Yeah.
Ah. We're not making this sound like very fun, guys.
So in this case, you'd probably just looping over point. Oh, what is this? Is this the functional function type? This is the function type. So in that case, you'll just be looping over. It is a param too. Oh yeah, because the reason is because of how it's passed. So the function type has the names. Oh my god. Yeah. It's all a mess. It's coming together now. So it should really have a param type thing that we just haven't implemented yet, apparently.
no.
Okay. Brilliant.
I'm definitely
Because-
going to make a t-shirt.
Yeah,
Yep.
because ideally the parameter names would only be stored in the function declaration because the type doesn't care about that but the way it's passed, would be annoying to do. So we're doing it this way. Anyway, it compiles now, it would seem.
It would seem. There's no promise that any of this is correct. But it does compile.
It does compile. So yeah, in this case, you can literally just translate the bit width. That probably just works. Yes. You need to find
Phantasmo.
the context to the size, but yes.
What's the in variable?
That's the parameter of the type we're going to convert. The opposite of out. It's basically a type from intercept.
Okay.
Okay,
I
I will
see.
say in is a bit of a cursed name for an in parameter. I get it's an in parameter, but calling it in. Okay, I shouldn't be talking because I constantly call out parameters out, but still.
Yeah, leave it.
I'm lazy, so I'd probably just call it T or TY or whatever.
Okay, so what do we actually... We should have types now. That like doesn't even matter. Now we need instructions. How do we actually make instructions? What's the thing there?
Same way we make AST nodes, and the same way
I don't know what that is.
It should be in LCC IR. It's the same thing. It's also just an AST basically.
So I call
for
new.
instance, yes, same thing.
Okay.
For instance, you can create an add instruction or whatever it is, or an int. So for integers, those are not technically called instructions. Those are just inline, just like the I in MIR.
Yeah,
So
that's fine.
that's probably called. I forgot what that was called. I think constant in constant, something like that. Immediate. I forgot what it called. Integers. But there's
Oh, no.
somewhere in here. Okay, that's intrinsic. Good God.
You haven't given me much to search.
Yeah, that is true. Zero extend, sign extend. Okay, integer constant. There you go. That's what it's called.
We did it.
Is this how that works?
Depends on how it's defined. You'll have to search
Yeah,
for
what
that
is
on
mod?
value. That's where the operator new is.
Oh,
I think they usually
Jesus.
take in a. I'm pretty sure it takes in a reference to the module.
I typically make it take a reference if it's the module. It's either way works.
This isn't the right
So
one.
you already got a mod, so you're fine. You can remove the
You
star.
can just pass along mod.
No, I
No, you
cannot.
can just delete. You can just write new mod. You can. Oh, it's an intercept mod. So the intercept. Okay,
You
Oh,
hold on.
guys aren't looking at the
you're not
reading, I
namespace. Who's
know.
good at C++
Hey.
now?
Why is this a free function and not a member function in IRGen?
What?
Because then you could just directly access the module.
What are you talking about? This
Why
thing?
is okay?
The generate expression.
Okay, why is generate expression not a member function of IRGen? That kind of defeats the point
Because
of
it needs to
having an
be
IRGen.
recursive. What are you talking about?
Why does that matter in any way, shape, or form? It can just call itself if it's a member function. That doesn't change anything.
What? So we're generating a context. So we create a module. We don't want to create a module for every expression we
No,
generate.
he's just saying create generate expression as a new
Generate
member type.
expression should be a member function of IRGen.
Okay, it can be.
That's,
What does
just
that
means that you don't
change?
have to, so you can get access to the correct
You
module
don't
without
need
having
pass
to.
in the module every time, and you also can directly access the LCC module because that's stored in the IRGen struct, which would be the only reason for having that. If you're not storing all of the context in the IRGen struct, then there's no point in having an IRGen struct.
Well, I didn't design it this way.
This is true.
I created the IRGen struct, but I didn't model it this way. There was stuff in there, and now there's not. Because I had
You're
to
in the wrong
use...
directory for that. That's probably in intercept, not LCC.
The IRGen? Yeah, it probably is.
I don't know where you put it. You know that. But it's probably not in I. There you go. So it does store the intercept module. It should also store the LCC module, probably, which the constructor can just create instead of generate, or either way works.
How do I do that?
Preferably, probably not in here, but rather in just the in the CC file or here.
What do you said in the constructor? This is the constructor.
Yeah, but you can also define that in the C file instead of in the header.
So,
Um,
so do I put it here? Do I create the in the
you
constructor?
can do it here if you want to. Sure.
Okay.
Woo.
I mean, you can try. We'll see if that works. If it has the right headers here, that's my main concern with declaring that in here. Oh, this should probably be a unique pointer because it'll have to be moved out of here.
This needs to be a unique pointer, the
This
member.
needs to be a pointer of some sort. Definitely not just in
Okay,
here
yeah.
because you'll need to move that out of here later.
You're using here in relative terms a lot.
Out of the
Within
IRJ.
this struct, it's not supposed to be it needs to be on the heap somewhere because we need to pass it around, but we can't move a module because that's insanity. So we need to put it on the heap so we can move it.
Time to do name resolution. Let's go.
Why is this? It's not mad. It's
So
just
for this, I would just call it just mod and int mod because no one is ever really calling into the IRGen struct. All of IR generation is just going to be in this struct as member functions. So
Yeah.
all of that can just access the fields directly. So you don't need the underscores in that case, really. Because you're not going to have a module function.
okay. That's
You can
fine.
just call it mod or module or whatever.
So can I do this now?
Probably.
I don't even need the declaration. Ooh. And then this
Sure,
should
that's
be
one way of doing it.
I'm pretty sure standard unique pointer wants a constructor anyway, doesn't it?
No, you can do this. That is fine. That should be fine.
There's a squiggle there. You told me it was not fine like a week ago.
You should be able to
Also,
assign a pointer to
think
a unique
it's
pointer just
fine.
fine. Typically.
well, we're gonna see if it builds.
I'm not sure it's even possible. Yeah, it's not possible.
Maybe it's just null pointer. That could be the case.
Yeah, because you told me like last week when I was returning something,
What
you
you,
have
what
to.
you actually should be doing is not that, but rather call standard make unique.
Because of
And you
course.
pass in the type as a
And then-
template parameter, and there we go.
So the tokenizer just uses the EBNF and not entire words or numbers. Oh dear. So the EBNF or BNF is just a way to define the grammar. It's not an implementation of it. Why is this mad? No match for operator star. Like it's using the wrong module. It's frozen because of ClangD. I love it.
Yeah, it does
I've-
that sometimes.
I've disabled almost all of my extensions in VS Code at this point, and I'm just kind of winging it.
I just restart CLine whenever ClangD refuses to do something. That happens sometimes.
It's already useless, so I'd rather it not try.
For me, it isn't because in
we go.
CLine it is way less janky than it is in here currently. It actually underlines the things that are errors, actual errors, and that helps a lot because I don't have to recompile every time. I can just
Yeah, but it
see
doesn't work
that-
for me. So
Yeah, if it doesn't work, then it's pointless. For me, it works. So
By the way, there's another reason for this is because of the namespace resolution. So that we could be only in the LCC namespace while
Mhm.
working on that. But now it's going to be
yeah,
an
again,
intercept
for that,
namespace.
the alternative would be to call the struct intercept IRGen and put it in the LCC namespace instead.
We'll probably do that eventually.
And now you no longer need to pass in the module as a function parameter. Because that's what the context is for.
Okay, expressions and stuff. New mod. What are we doing here? This is either going to be int module or module.
Don't need the star, is what's going on. Oh, you do need the star. Yeah, module. You called it module, not mod.
Yeah,
Again,
because
I don't
that's the
like
full
typing,
word.
so I just call it mod.
I don't like C++, but here we are.
We are making compromises, everybody.
You probably want to pass in the value to the integer literal, just saying.
Probably.
Oh, you have to put the generate expression in the header file.
Yeah.
Yep.
That would help, probably.
Return type.
It does need a return type, that's true. Yeah. Probably just return void or something.
Cool.
K4YDF, what you think about assembler? Assemblers are cool. I like assembly, the language, more. Ha ha.
A language family.
Yeah, it's not even really a language. It's just an idea of a syntax.
Hmm.
Cannot call member function. Why? For
Without
why?
object. Are you in a static function? Probably. Generate is a
Yes.
static function. No, not that one. So
So
no,
this one
not
has to be static.
no.
Generate needs to be not
No.
static. Oh
No,
boy.
no,
We need to-
stop,
yeah.
stop.
Gotta
Stop.
stop thinking for 2
Think.
seconds.
Think. Go back to the terminal, read the error.
Yep.
Read the error and try to understand it. That's the only way you're gonna
It's
make
cannot call
progress
the member
ever in
function
this
because there's
language.
nothing instantiated. So do we instantiate one? We just have to
No.
make a stupid IR gen?
No. Okay, let's
I mean, yeah. but-
let's go slow because there's a problem here that something is not being understood correctly. Okay, generate is a static member function. A static member function doesn't get an object passed in. Generate
understand
expression
that.
We
is
know.
not a static member function, so it implicitly
We already
parameter.
got there. We read the error message. He's just saying there is no instance of IR gen yet, so he has to create one.
Okay,
And that's what he was
make
about to
one,
do.
yeah.
So what's the solution?
Create an
Needs-
IR gen.
That's what I
IR
just
gen.
said, and you said no.
That's, yeah. No, I said you were right, and he said he stopped listening to us when he thought we stopped listening to him.
Well, you were about to make generate expression static, which does indicate a lack of understanding.
Only
Has a
because
little
you
bit
said
That's
no.
actually
That's the
true.
second thing.
Yeah, we were gonna make IR gen first.
Yeah.
Oh,
I said, so I make one, and you yelled no.
the Three Stooges. Let's go.
It happened way too fast.
It did.
You're going too fast is my issue, yeah.
Too fast.
I'm sorry you're slow.
Yeah.
Yes, I prefer taking things slow because that way I make fewer errors typically.
See, but that's at direct odds with typing lots of characters.
Yeah.
Yes, I also despise typing lots of characters. That's why I do short names for everything.
Uh-huh.
Because
Actually,
I
I
can't
have to
type well.
remove static.
We're just saying.
That is okay. You, that works, but it's very funny the way it's highlighting it because it's highlighting it as a function declaration because you've
Indeed.
run into the most vexing pass there. In this case, it works, but yeah.
Oh my god, we got there in the end. I need to do something about this. This is not.
It's now saying we
probably-
can't do this. Did I leave the static? I left the static.
Yeah,
Oh,
well,
no.
I would do it.
Well, you were yelling at me not to. I had to do it.
So
Oh my god.
probably, yeah, you forgot to pass in the value. That's the thing I mentioned earlier. Yeah, that would do it. I think it also does it also take a context? I'm not sure. It takes a type. That would make sense. It takes a type and the value.
What? What type?
Whatever the type of the integer literal is, which currently might. Well, it does matter for the IR. The IR does care about that eventually. The expression should have a type, so you can just call expert type, convert expert type, whatever, and context also. Yeah.
Where is it? What is integer constant?
What is it called? Is the question. Is it called integer? So that's the
Value.
integer constant in the
Jesus.
IR. No, careful. That's the expression, though. You need to get the thing from the expression. So you'll have to cast it to whatever an integer literal expression is, which I forgot what it was called. You can just search for that and you'll find it is called integer literal. There you go. And that does have a value on it, yes. But you need to cast it to that first, because currently it's just an expression. So yeah, this is like the main annoyance when it comes to dealing with these kinds of data structures, that there is no match statement or anything like that. So you always have to do this either this weird thing you have chains of like if else or if const expr where you cast to that and then you have and then you have a pointer to it, or you could do it with overloading, you can do it with visit, or you end up with a switch statement where you have to cast anyway. So there isn't really a nice way of doing this without always like listing this twice, because there is currently no match statement or anything like that.
So I have to write the function that like adds stuff to a function.
So wait, what are we doing?
I have to the IR. I have to write the function that adds an instruction to the function. We haven't done that.
To a block, yes, that could probably also just be in IRGen or something.
You think? Where?
Because you could make that a member function, for instance. Just insert instruction or whatever
Make what a
Or just
member of what?
of IRGen.
What?
That would create an insert function that inserts inserts an instruction wherever you are. Not that it matters for integer literals, because those are not for integers, because those are not supposed to be inserted, not instructions. So for this, okay, so for this you have to know something, and that's values are not instructions. Values could also be a function or a block, so it's inst, yeah. And this should probably just insert. You can make more insert functions, of course, but currently we just need one that inserts it at wherever we're currently inserting, which we probably also need to store. That's the insert point thing that we had, because you don't want to be passing all of that in every time. It gets kind of annoying.
That's what gets it.
So we have this. We still have to know which is the current block and stuff.
I would just store an insert point, a block that's the current insert point, and we insert there.
In here.
No, in IRGen, because that's what we're inserting.
You're like it's like globals in C is what I feel like you're recommending. You're like, yeah, just make it all
a
globals. It's
concept.
fine.
Yes, because that's the point of having these kinds of structures, and it's not global because you can have multiple instances in the same program. That's the main difference between globals and this. And the main problem with globals that if you can't do multi-threading and stuff like that with them.
This is a mess.
It has a lot of state. That's just how it is.
I mean, you do the same thing in C with just a struct that you pass around by pointer.
Yeah. Except here you don't have to pass it around
Now
manually.
it's just this. Okay. God damn.
So these probably just only get set when we cogen a function.
what about block? How does this work? What are the semantics of this? Is block null pointer, and when we go to add to a null block, we create it?
Well, we should never call insert before when the block is null, because the way I would do it is we have this top level generate function which creates the IRGen struct, and then it then code gens every function individually, because that's the only thing we have at the top level is functions, or at least conceptually it loops over every function, and then within that loop, at the start of that loop, it creates the function, all of that, and then it sets the current function to that, and
Generate the
this should
function
also
body.
create a block, like the function constructor should create a block if it's not extern. So if it's not extern, we can get the block, the entry block.
What? How do I know
Okay,
if it's extern or not?
Currently, I believe
Linkage?
you can check whether the body is null, for instance, or you can check the linkage and check if it's imported. Again, I haven't used most of this API in this way yet, so I'm not sure if it's fully implemented yet. But there's two ways of checking that.
Probably use convert here now.
Probably yes. Oh no, it already does. You already do that on line 112, except manually.
Isn't this just the
This
function
is just
handling?
convert. Yes, that is just convert.
Okay. So what do you... If this is null, what do I do?
If this is null, it's extern, so there's no body to generate. So just
Continue.
continue. Or that, sure.
Yep, there we go.
Also, I would not recommend setting the linkage to export it every time. You can just get the linkage from the function.
Yeah, I'm pretty sure I ran into issues with that. That's why.
Well, it's a function, you have to call it, so it's f linkage.
Sure.
Let us see.
That should work since the linkage is the same in everywhere. Some problem with the constructor, apparently. Invalid use of member. Oh, again, you can't assign to function because this is generate itself is not in the. So you have to do instantiate the instance dot function on line 103. I would recommend a shorter name for that. That might help. Just saying.
Eh.
103 still needs the assignment too. There we go. And you missed a comma in the invocation of the constructor after convert. There you
That
go.
would do it. You need to, okay, it expects a
Cast.
function type. You need to tell it that's a function type. So you have to cast that to a function type. No, not like that. You should be using as for that. Because that checks that the cast actually works. Invalid
Active
use of
boys.
void. Ah,
That's
wait, what?
Yep, that's your error in the as cast again.
Oh.
So
I see. Because so, wait, hold on. Can you show me the?
because it's a pointer, you don't need the pointer in there.
Yeah, it
As
should.
LCC function type with no pointer.
Yes, don't put the point to that.
There we go. Yeah, your assert generating that weird error is not very helpful.
Is the assert not? There should be a static assert for that, isn't there? Oh, it's
Yeah,
just
It trips,
checks
but then
content.
it cascades anyway.
Yeah. It says it on there. Static assertion failed. Target type of cast must be a const qualified class type. The one above that.
Anyway, so now it should work, right?
Mm-hmm.
Did you recompile this one?
Mm-hmm.
I thought that would work.
Okay, so what do we have to do now? I guess printing out the IR would probably be important. We're gonna make committees.
Committee.
Big ol' committees. Sloppy, wet, hanging committees.
Huh?
You know, commits.
Hmm.
7 now compiles and does not error on run, but also it does nothing. It's fantastic.
Was it erroring or something? Oh, that's lie. I see.
Huh?
I was gonna say,
Your
was
error
Sema
must be your
erroring?
commit message.
Oh.
Mm.
Alrighty. Committees. What did we have to change? Why are all these different?
Because you all changed the context from the reference to a pointer.
Ah, thank you. Implement get is what we'll call it.
This is gonna take a while to implement, just so you know.
All of IRGen?
The entire compiler for sure, but IRGen too at this rate, probably, yeah. Like, we're definitely gonna get nowhere near done today.
No. That's fine. And
Is there anything else? Oh, go on.
in fact, it's probably a good time to end it.
Is it?
Yeah.
Is it? Okay.
There's pretty soon. I mean, we still got some time, but
That was short.
Okay. It's late too.
I mean, it was longer than the last one, wasn't it?
It's been an hour and a half.
Yeah.
We are 1.5 hours in, no, almost.
Okay. Intercept
Bum, bum, bum.
IRGen, type conversion, and some very basic IRGen. Did we even get any IRGen? We did.
Mm.
IRGen stupid instantiation. We're using that, luckily. We're blessed with the idea that is having a static function that creates the class that it's a static member function of.
Mm-hmm.
That then calls non-static member functions on that class. I feel like
yeah,
this pattern.
probably that loop could probably be its own member function. That would probably make this easier.
Yes.
Because that's more or less what the you can check what the how the parser works and how Sema works, because those do the same pattern basically.
Makes sense.
Yeah, I don't know why we decided on it, but we did do it.
The main reason is because what are you gonna do with a parser instance other than parse an entire file?
Yeah, so you don't need to hold on to the
Nothing. So
instance.
there's no point in really exposing that.
So it's kind of just like a block expression is what it's acting like. Like just
Well,
Yeah,
sure.
generate. It's kind of like this.
Sure.
Yep.
It's just a
Mhm.
function.
For
You can check Sema or the parser for intercept. It's the same thing as this, basically.
Oh, someone in chat is asking, how do they get into stuff? Like making their own compiler. They're saying, I learn EBNF and then what? Oh boy.
That's a loaded question.
I know.
Ooh.
So
Yeah.
basically, write programs that aren't compilers. This is my advice to you. And then write a compiler, because you'll have so much more understanding and knowledge going into it.
Yeah, if you understand how a natively compiled language works, be it C, C++, or Rust or whatever, then maybe think about a compiler. But if the only thing you know is JavaScript or Java or whatever, then you're probably gonna have a hard time.
Now, if you do write programs often, and you really are just asking, how do I start writing a compiler? Because I programmed for like 8 years and I had no idea how compilers worked, and I legitimately did not know where to start. Then, yeah, we can give you some pointers, but probably clarify that first before we babble nonsense at you.
Alternatively,
Watch the series.
yeah.
Mm.
Watch the last about, I don't know, 10 to 15 days of footage. And, just catch up.
Yeah, just catch up.
Yeah. And then those 10 to 15 days, you know what's going to happen? I'm going to stream again.
Mhm. I can always recommend the Crafting Interpreters book. It's free online. It gives you everything you need to know about interpreted languages. And that is, I mean, the first half of any language is the same, no matter if it's compiled or interpreted anyway. So you'll still get the starting point and you'll start to understand how compilers work.
Mm-hmm.
What's
It's just a series of steps. You do something in the step to transform the data until you get to your code or your bytecode or whatever. So you just got to learn what those steps are and how they work.
That's right. This,
Oh yeah, just because we're looking at this right now, just a quick remark. Yeah, how it says do not reorder these up there. That is true for all of these kind enums. I just didn't write it on all of them because I get tired. But don't reorder any of them because there are parts that check if it's greater than and less than something.
just so we have
so-
groups of like all the
Yes, for instance,
declarations.
typed expression, I'm pretty sure just checks if it's vardecal or greater or whatever. If it's greater than vardecal, that's why they're arranged in that way. And decal checks if it's a struct between struct decal and func decal or whatever it was.
You've constructed a system in which only you can work on it.
Well,
I
if you're
helped.
familiar with how it works, then
We could reason about it. You're right. We could figure it out. Like we could add something and see what breaks, or alternatively, just go like I want to add one here, and then figure out what actually you'd have to go through every single one and figure out what comparison.
well, it depends.
does.
They're arranged in blocks basically. So if you add an expression that has a type,
They are arranged in blocks, but you did just mention that you have a class that starts halfway through a block and extends to every block below it. So not entirely.
yes, sure. Like when I said in blocks, not with how they're like divided up here, as in like the. For instance, if you have a decal, the things that are decals aren't like split all over the place. They're contiguous, is what I meant.
Mhm.
And the things that are typed expressions are also contiguous. And the things that are object decals are contiguous, and so on. That's what I meant.
Better not have something that's three cases that don't overlap.
Mm.
Shouldn't happen, but hypothetically.
It's a graph theory thing. How many colors?
It is a tree, technically, the entire thing. So
What's an
you've
easy
always the
one?
The AST models a tree and is itself a tree in terms of how the inheritance works.
What's an easy one to IR gen?
An easy one to IR gen, you just did integer literal. Other than that, none of
That's
them are
gonna be-
really simple, I think.
Okay, then it's a
All
good
of
time.
All of them are binary expressions. You have to go through all the operators. If you have to
Just
do
limit it to
finite-
operator plus and then throw on everything else.
Sure.
That's
You
what
know,
I'm
with
doing. I'm
wraparound,
scaffolding.
you can technically do every single operation just plus.
There you go.
Oh, yeah. Mobfuscate a moment.
That's right.
Anyway, what was I going to say? Oh, yeah, because you mentioned this style of RTTI is the LVM style of doing it, by the way. I didn't come up with this.
Yep.
So I guess my job is now to figure out the GCC way of RTTI and implement that, and then we'll
Yeah,
use
yeah.
both.
The GCC way of doing things is I think they still use Gen G type or something custom. Like GCC is fascinating in terms of how this compiler even works. Like everything is just a macro, and it's interesting, definitely.
It's going to be like how intercept is.
Or Porth or Corth when we implement Corth into the front end.
That's right.
Everything's a macro.
Yeah, I think I've mentioned that before, but you can clearly see a difference between GCC and Clang in terms of the code base, but that's also because Clang was designed with modularity in mind and to be consumed as a library because it started as a research project. It's also why that and the GPL restrictions and all of that are the main reason why everyone who wants to work with to parse C++ uses Clang and not GCC, because it's easier to use and also has the more convenient license for people who want to use it for
Easier to
proprietary
use
stuff.
is still a very relative term.
It is still a C++ compiler. Yeah, sure.
I want to go back to a time where all we have to do is parse C. How do we delete C++ from the entirety of mankind?
It's hard enough when you get to because there's a difference between passing a function that just prints stuff or a little C program and passing Windows.h.
Yeah. I mean, I'm still planning to do it. I'm going to power through it. But I know I'm not going to do it first try. It's going to take me a while.
There are cursed things like there's such a thing as 32-bit pointers in 64-bit mode. I'm pretty sure MSVC has an extension for that and other cursed things. So good
MSVC
luck
has
with that.
extensions for so many things, and I don't like it, but I'm gonna
Yeah,
try to do it anyway. We'll see
why-
how far I get before I burn out. So long as I can, if
generally.
I can parse standard C, then I'm done. If I can then have the willpower to pass any of the other compiler extensions, I will try until I give up.
Because it's funny because even passing standard C is not going to be enough. Because it's funny because I'm not sure if you saw the recent sorting video where he tried passing C with a Python program and it errored on built-in VA list, because of course that's not defined anywhere. That's defined internally by the compiler.
Yep.
So, and also I'm pretty sure GCC uses like glibc, not even GCC, glibc uses statement expressions and things like that somewhere internally.
Yeah.
So
Well, I'm not saying, like, again, I want to implement a C
like
parser for my own purposes, not for parsing headers from system libraries just yet.
Yeah. I'm just saying if you wanted to parse system library headers, you'd have to be able to parse more than just standard C.
Yeah, no, I'll get there eventually. I just want to personally parse regular old C.
Yeah.
Because if I can do that, I can write my own system library headers that don't do that.
Ooh.
It'll be a manual process and it'll suck, but I'll do it if I have to.
That will suck because making that cross-platform would be a pain.
Oh yeah, no, I'd have to do it for every platform I plan to support the parsing on. Don't worry, I know it's a stupid idea, but I'm stubborn and I'm gonna do it until I die.
Sure.
Because it's either that or link with Clang, and we're not doing that right now. If ever.
Never.
So if I want to parse C
issue
files
with-
for Laye, then I have to do something.
Yeah, the main issue with linking with Clang is that you need to be able to compile Clang. If you can do that, the rest is easy comparatively.
Yeah. Yeah, and if Clang changes to the point where it's like easy to compile for multiple platforms and it's like, it just builds in 10 minutes or even 40 like GCC.
Well, it
I'd
depends
love
on
to
the
just have
system. On
binaries,
my
please.
system, it does build on 15 minutes, but I have a fairly decent CPU.
I just want them to provide nice pre-built libraries and headers for everything that I don't have to
That's
think
also
about.
a thing. I don't know why they don't just supply the static libraries too in the releases.
Mm-hmm. It would be nice. They're a big enough project. They can afford to do it.
It's also weird that they don't include a lot of the Clang tools in Windows too. Like I think it's what was it, LLC and LLI are just not there on Windows.
Yep.
Which is weird.
All right. I think it's a good time. We did some IR gen. There's still more to do, but we got a lot done. We can now convert intercept types to IR types. Hooray. Does anybody have anything they'd like to plug that's in the Discord arena?
I haven't been streaming as much as I want, so no, not really.
Go subscribe to Local.
Do it, and I'll stream eventually.
Yes. Eternal has a
Yeah.
Patreon. It's in the description. Go check that out.
Oh yeah, I do. That's true.
Shit, I gotta make a Patreon. People gotta give me money, but then I
Mm.
gotta make stuff.
That's the main thing. Yeah. I'm not sure, or because I can put some programming stuff on there, sure. Most of the stuff is on GitHub anyway, though. For me, the thing is also that the things I work on with Agma, I typically they're like supposed to be secret until they come out, so I can't post too much of that on there.
Yeah. Just spoil all of his next videos. That'd be terrible. All right.
Well, what I can say is that currently the document is at 26 pages, so
What the hell?
If you go to youtube.com/LENSR, you'll find my channel. There's a bunch of videos there. All 68 of them now. I can't wait for the next one. And there's lots of content there, so if you're interested in that, go suck on those.
did you ever end up making a second playlist, or is it still the same?
There's two.
There is two. I see.
So yeah, if you want to see the C++ rewrite ones, there's a new playlist and a new year.
Hmm.
But yeah, be sure to check that out if you are interested in that sort of thing. Obviously, all the code is on the GitHub. I have other projects on Codeberg, which you should also check out. Codeberg's awesome. Like my OS and my text editor. Go check those out. They're fun. They're actually what they sound like. It's an OS and a text editor. They're hard to make, and I've done that. The Lenser compiler collection is accepting PRs, as always, in the CPP rewrite branch.
Which is currently 184. Good
We're making
God.
progress.
That's right. We're
The
making
thing is,
progress.
the scary part is we are 184 commits in, and we're just getting to our generation now. There's
Mhm,
gonna be 500 commits at least when you're done, or something like that.
Yeah,
Probably.
I'm not sure I even want to put a number on it, candidly.
not yet.
I'm also taking a break from it currently a bit and working on some stuff for Agma because I just got done with all of the parser and Semma, so
Mhm.
That's right.
It took like a 2-day break, but we'll see. We'll see how work goes.
And
I'll
I'm here
implement
as
the
always.
LVM backend once IRGen is done because that's simple. Comparatively.
I'll use it.
Then we can actually start testing the code and figure out where the bugs are.
We'll very soon have an assembly backend because those are simple.
Yeah.
Mm-hmm.
Yeah, you do the assembly backend. Yeah, Eternal does the LLVM backend. I'll watch.
The main thing with the backends is that the LVM backend will be done early because it doesn't rely on all of machine AI, instruction selection, register location, all of that.
Exactly, yeah.
Yeah, so you do that soonish, and then I can run Laia code, and I'll be happy.
Yes.
Hey.
Also, local, let me know
Mhm.
if you need anything else in the IR for Lion.
If I need something and I don't know how to do it, then I will let you know. But I
Sure.
will make that attempt myself.
Okay, sure.
I understand how IR works, so I can do that.
Okay, yeah.
We did it.
Woo.
But yeah, be sure to check those things out that I said you should check out. There's also links in the description. There's probably a donate button. There's the links for the wonderful people in the Discord right now, local and eternal. Be sure to go click those buttons, and that's all. Bye bye, everybody.
Bye bye.
Ta-da.